Please give a round of applause to Sebastian.
Thank you for introducing me. Thank you for having me. As you just mentioned, I'm talking about testing and documenting event-based software this morning, but I also managed to sneak in a section where I talk about a feature in PHPUnit that, to the best of my knowledge, I have never talked about at a conference before. And I'm not really sure, come to think of it right now, something that I need to check after the presentation, whether or not I have documented that. So maybe I have something to do on the train back home tomorrow. Anyway, welcome to testing and documenting event-based software. We're talking about events and how to get insights from those events that go beyond, is probably the wrong word, but I cannot think about a better word at the moment, that go beyond just helping us understand what the software is that we are about to build, that we can use to also guide our testing effort, and maybe we manage that by running the tests, we get full circle and get back the information that we gathered at the beginning. Talking about beginnings, I would like a quick show of hands who has at least some experience or knowledge about event-based systems. Have you? Oh, that is a lot of people. That is more than I imagined. That is nice. For the others, I'm going to do a quick intro and then we'll focus on testing and getting useful insights out of those events. So an event-based system or an event-sourced system, when we have something like that, that usually means a lot of different things, but the most fundamental thing is that we do not just record in our world the current state of the world, but we keep a record of everything that has happened from a domain perspective in our software. So the Hello World example of event stores or event-sourced software is that of a bank account, because at some point something has happened, €1.23 was deposited into an account. Right? But of course, a story like that never happens with the first thing that you look at. There's always been some history before that. So maybe there was something like, hey, deposit €1.23 into that account. That would have been a command. Right? And then if we look at all the events that have happened over time that relate to one particular customer or account, then we can recreate, based on these records that we kept, the current state, and that is the balance is currently €1.23. If we simplify our world enough and consider for a moment that the history of this customer relationship, the history of this bank account has actually begun with the command that is currently on the left. Spoiler, it's never that simple, right? So the current state of the world is the balance is 123. That is called a projection or a read model, something that we can look at for quick access to information. What is the balance for this customer, for this bank account? The orange sticky note is a so-called domain event, something meaningful that has happened in our software. And the blue sticky note, that is a command, something that came from the outside into our system, commanded us to do something or try to do something. And usually the outcome of such a command is that something has happened and that we record as a domain event. And in case I have not mentioned that yet, domain events are immutable. They reflect what has happened and we cannot go back and change history. As I already mentioned, usually a lot more has happened before. So this is probably the smallest complete, whatever complete may mean, sequence of sticky notes. So we open an account, and an account was opened, and then we deposit some money, and then some money was deposited, and then we know what the current balance is. Well, there's even history before that, right? That's why these people that do things with events and really like events, please, just because I'm talking about testing, not another fire testing thingy. Okay, good. Seems to have worked. Andre should have tried that. That's why these people that like to do event storming workshops, where you have a lot of people that use these sticky notes on a wall, always say at the end the wall is too small, we need a larger canvas, because either there is something missing at the very beginning or something missing at the very end. If you consider like the length, the width of your canvas to be the time, and you put your events in order to figure out what the hell is our system actually doing. But I try to keep it simple, so somebody like potential customer comes and requests an account, and then the account was requested, and then we delegate to an external system that is out of scope for what we're currently working on to make a decision. Do we actually want to open an account? Do we want this customer? And then we call the open account command, and then the event will be recorded, the account has been opened. Maybe the external system tells us, hey, reject this account request, this looks fishy, fraud detection, whatever, we do not want to open this account. And then the outcome of that is a different event, namely the account request rejected event. So we have a complete history with all the information that happened along the way, and not just, hey, we either have an account or we do not have an account, which is the current state. We have everything that happened in between. And if you ever wanted to know what that infinite canvas event storming thingy looks like that I just mentioned, this is a photo from one of the event storming workshops that I participated in at some point in time. I did not facilitate this one. This one was facilitated by my two partners, Arne and Stefan. You can see them in the background. And I don't even remember what we event modeled there. If you want to learn more about event storming, this QR code will bring you to Alberto Brandolini's book, which is probably the best resource about event storming. If you want to learn about that in practice through a workshop, then either this QR code or this QR code will be your friend. Anyway, back to the example. For today, for the remainder of this talk, I want to focus on two events out of that stream of events that we have just seen. Makes it easier to think about things when we are talking about a smaller scope. We will focus on account opened and money deposited. So if we have these events and they have been recorded at some point in the past, as I mentioned earlier, we can look at these events to recreate the current state, or in other words, in the lingo of this type of software development, we can use these events to source the current state. The events are our source of truth. When we look at the events to recreate the current state, that is event sourcing. And code to do that, code to recreate the current state of this bank account from the events that correlate with it. It can be really simple, can be as simple as, okay, I look at all the events for this bank account. The first one that I find is account opened. And then it's one line of PHP code. I create a bank account object, put some information in there, and then I can continue processing the next event. And maybe the next event is €1.23 has been deposited, and that is just another method call on the bank account object I have created by processing the account opened event. Yeah, if we put that in perspective, if we look at, for instance, the bank account event sourcer class, and by the way, before I talk any further, On all the slides that show source code, you will see a QR code in the lower right corner if I'm not standing in front of it. Sorry about that. But there are plenty of screens around the room where you can see that. And all those QR codes will go immediately to the source code file that is currently being shown in a repository on GitHub that has the complete source code for a application that does exactly what I'm showing you here, including the tests that you can just run by checking out the repository. Okay, so our bank account event source or object is in our application the object that is responsible for looking at a sequence of events and reconstructing a bank account object from that. And it does so in a, like, this is really boring code if you look at it beyond the high-level concepts of event sourcing and domain events and things like that, because it's just a loop that iterates over some objects, and depending on what the object currently is, it does something. Not really something that you should need an LLM-based agent for to generate, but feel free to do that. So we iterate over those things. When we encounter account opened, we do what I just explained to you, and the same for deposited. And of course, there are some other events. Maybe we want to close the account at some point. Maybe we also need to withdraw money at some point. Maybe we want to do a wire transfer, things like that. Where do these events come from? They come usually from a command processor. Remember the blue sticky note from earlier? That was a command given to the system. Hey, deposit €1.23, and the outcome of that should be an event that is being recorded. €1.23 has been deposited. So where does this event come from? It comes from a processing deposit money command processor in this case. Sorry about the processing prefix, but that's the best naming I have found so far for the class that actually implements the interface behind the scenes. And the interface is useful for testing things, as we will see later, as is usually separating interface from implementation. If you do that, then a lot of things with regards to testing become easier. So our command processor takes this command, wherever it may come from, and the command encapsulates all the information that we need to process it. And the command processor does just that. It tries to perform the command. If we run into a situation, hey, this bank account has been closed, you can no longer deposit money into that. The result, I don't know what the result will be because I did not implement that. It's a minimal example application, right? But it will definitely not be the event, hey, this money has been deposited, because that would violate our business rule. In this case, everything is fine and we get that event, and it's the responsibility of the command processor to perform the domain logic that is needed to perform the command, and then to record that this has happened. And the recording that this has happened is what the emitter dependency of this command processor is responsible for. We tell the emitter, hey, there is a new event that needs to be recorded. Money has been deposited into this account. It was this amount. And here is a description. And description is, in this case, really simple text that would tell something, hey, somebody went to an ATM and deposited money, or someone deposited money in some other way. Okay. If we talk, I just mentioned the term domain logic. There's different types of code in our application, and depending on how upside down or whatever angle you want to look at, this is my preferred angle of looking at it. It starts with the application logic. That's the first piece of code that gets run when a request comes in. This is usually your framework code that makes a decision by looking at the HTTP request that is coming in which piece of code needs to be executed. This is where the routing happens, where a controller, an action, whatever your lingo for that kind of logic is, gets selected and run. Then comes the domain logic. That would be the bank account object in our thing earlier, which we need to source and things like that. For that, we need supporting services, supporting functionality. And these are things like repositories. And repositories can be classic object relational mapping based repositories that use Doctrine or similar libraries to map objects to and from persistence. But it can also be a repository that knows about event sourcing and that knows, okay, I need the bank account object for this current customer that just logged in. Now I need to delegate to an event sourcer, which uses an event reader to read from wherever our events are stored to reconstruct the bank account object that we just need. And of course, we do not just need to be able to read things, we also need to be able to write things, and that's why we have next to the event sourcer and the event reader an area of the code that deals with emitting events and persisting events that have happened. And below that, it gets boring, at least for me, because that is stuff that we should all, I trust that we all have been doing this for a really long time. This is using database APIs or other APIs that our programming language of choice provides us with to talk to the outside world, talk to the file system, talk to a database and things like that. Maybe we have a slim layer on top of that gives us some more convenience or allows us to enforce some architectural constraints, which is something that I really like to do. If you want to look more in depth into what I mean by that, look at the example application for which I showed you the QR code earlier and for which I will show you the QR code a couple of more times, because that has a strict separation between reading from the database and writing to the database. There are separate users with different privileges. Like if I'm in a GET request, I know I'm not going to make a change to the state of my system. So I don't need to do any event emitting. So I can just I only need an event reader. So I only need a database connection that is allowed to do a select statement. Yeah, so I am not an expert in security, and I don't really want to go into security because I think testing is more interesting, which is good because other people are not that interested in testing and they're more interested in security. But one of the things that I picked up over the years, that this privilege separation and minimal privileges and not using a user to talk to the database that can read and write when you know upfront that you only need reading, that really helps a lot in making things safer. Which is ironically not the reason why I do that, because for me it makes it easier for me to think about my code. When I look at a piece of code and I see the only dependency that comes in here is a reading database connection or an event reader, then I know the piece of code I'm currently looking at that cannot emit events, that cannot write to the persistence layer, and that reduces the cognitive load that I need to invest while trying to understand this piece of code and do whatever it is I want to do right now, which is why I'm looking at the code. Right? That makes it easier for me. I don't know about yourself. I cannot speak for yourself. I can only give you my subjective experience, what helps me. Okay, so if we look at all these layers, and of course we have a database beyond that and under that, and we have PHP as a language, and we have the operating system and everything else, which does not fit on screen. Sorry about that. If we look at all of that, at some point, the question comes up, what do I test and how do I test that? and which of these parts, which of these layers, which of these areas in my software can and should I test in isolation from the rest, and where do I need combinations. So of course I can write simple small unit tests from my application logic. I can test my routing. When a GET request comes in that looks like this, is the right piece of code selected for execution. That is simple. I do not need any of the other layers below that. That is great. I can and should, and I would say I must, I have to be able to write unit tests from my domain logic for the things, for the objects that implement the core concepts and rules from my business, from my domain. And I want to be able to do that in the smallest scope possible as a unit test, because I want to test that without talking to the web, without talking to persistence. Yeah, domain logic should not know that something like the web or a database or any other system around it even exists, and that makes testing a lot easier. I can write unit tests for my repositories. I can write integration tests that test the two topmost layers in conjunction. Yeah, I can send a request to my application and test, does the application logic select based on the request the right domain logic, and does this domain logic then do the right thing while stubbing or mocking everything beneath it. I can write larger integration tests when I'm interested in verifying that my infrastructure works correctly, that my repositories work, that my event system works, that my persistence layer works. I can write overlapping integration tests that test all the way from the requests comes in to the repositories, but not below that. I somehow simulate the real database. I can do even larger integration tests and say, hey, I just test the domain logic integrated with everything that comes below, but I do not want to set up a web server and go with an HTTP request into my application logic, and I just simulate the application logic in my test layer. And of course, something that always works, even when your software is not testable, is end-to-end testing. Right? I can make a real HTTP request from a real HTTP client going to my application, getting a real HTTP response, look into the response and make a decision, yes, this is correct, no, this is not correct. Right? And if we flip that, we get one of the classic visualizations for categories of tests. We have a strong foundation with unit tests at the bottom of our pyramid. We have an integration layer above that. And then we have edge-to-edge tests, which is as end-to-end as possible without using a real HTTP client and a real HTTP server. This is, for instance, if you're using what Laravel and Symfony, for example, called functional testing. You instantiate your kernel, you instantiate the entry point of your framework and call the execute or run method of your framework's kernel. Please execute this request that you prepare, and you get back a response object, and then you can inspect the response object. This is, in a lot of cases, as end-to-end as is needed to get a good feedback with regards to, does my software do the right thing? And it is a lot quicker to run than real end-to-end tests, but of course for finding some issues with regards to wiring up your application, you need end-to-end tests, hopefully only very few. Yeah, and the key thing about this pyramid visualization is that the higher the layer, the more feedback you get about, have I built the right application, which is something completely different, although the words are very similar. Have I built the application right? Yeah, the lower you are in the pyramid, the more feedback you get about, have I crafted my software correctly? An end-to-end test is not able to give you feedback about have I implemented my classes in a clean way. But on the other hand, the unit test also cannot tell you whether or not you have built the right application, the one that was actually required. Okay. If I run my tests for something like a deposit money command processor, then that is not rocket science. Sorry, I'm not going to introduce the fundamentals of writing tests with PHPUnit and running them today. But it's as easy as running tests for anything else that you probably have already done if you're using PHPUnit for a while before. And that is also not something new, but I'm mentioning it here explicitly because I still come across a lot of developers that have never heard about or even much less used the --testdocs CLI option of PHPUnit. That gives you a different output from running your tests, one that is based on the idea that tests are not just verification of your code, but can also be used as executable documentation, or if you're doing test-driven development, they are executable specification of your code, right? So if you invest a little effort in coming up with a meaningful name for your test method, you get a nice bullet point list of everything that there is to know about a class such as deposit money command processor, right? So what we see from this test, it emits a money deposited event when money is deposited. This is not new. This is something that has been in PHPUnit for almost 20 years. And every once in a while, I added more functionality to that, made it easier to customize the output, because sometimes you need to customize that, especially when you're working with data providers. So that is not something new. So I will show you something new in a little while, but before I get to that, I would like to show how this test that we just executed on the command line is implemented. Because over the years, while working more and more with event-sourced systems and event-based systems, I at some point discovered, hey, I would really like to reuse the language from my domain and the fact that the application uses events at the core of its architecture. I want to use that in the language to write the tests. I want to see that reflected in the tests. And then over time, I saw a pattern repeat itself, and I want to share that with you today. And the pattern itself is not something new either. It's the given when then language that behavior-driven development, for example, championed a long time ago already. But you can use this given when then approach inside your test and hide any complexity that you need to deal with when you want to verify that such an event-based system works correctly behind a clean and nice API. And this is what I'm going to show you right now. So in our deposit money command processor test, we use a method named given that is provided by the event test case. So event test case is a PHPUnit customization that is part of this project. And the idea here is as follows. For this test, I assume that these events have happened in the past. I want to test the deposit money command processor test. I can only deposit money into a bank account that has been opened. So I assume given an account has been opened. Given this account opened has happened in the past, and this account opened is a helper method, again, provided by event test case that knows how to construct behind the scenes the immutable value object that represents this event. So given the account was opened, when I process the deposit money command, and again, when and deposit money are methods provided by the event test case. When I process deposit money with these arguments, then I expect something to have happened, and what I expect to have happened is not the return value of a method that I can assert using an assertion such as assert same or assert true. It's also not indirect output in a sense that I have created a mock object somehow and injected that and configured an expectation. I expect that this method has been called. I want something that I read here when I look at this test code that is not that technical. I do not want to see assertions or mock expectations here. They, of course, somewhere underneath all of this happen, but they are hidden from the reader of this test code here, not because they are not allowed or supposed to see that, but because it would be distracting looking at this code and working on this test code. So given an account was opened, when deposit money command is processed, then a money deposited event should come out of that, should be the result of that. And underneath, PHPUnit manages the event system for you. That is all handled in the event test case. And if you want to be really fancy, you can have two different implementations of event test case. One that uses the real event system with the real persistence for an integration test, and one that uses stubs and mocks to unit test the deposit money command processor, right? And I can run this test. We have seen this before. But something that you have not seen before is that we not just get documentation from running our tests in the form of test docs, but through a really small extension for PHPUnit. And this is only something that became, well, it may have been possible before PHPUnit 10 and its event system, but nowadays it's really simple, at least if you read the documentation and look at some examples. It's usually really easy to figure out how to write an extension for PHPUnit that hooks into PHPUnit's own event system to, for instance, create custom log files. And in this case, visual documentation that reuses the notation, reuses the language of the sticky notes from event storming. And running this test generates a PDF file or an SVG file or a bitmap graphic file that has two orange sticky notes and a blue one in the middle. Given these events were emitted in the past, account opened, when this command is processed, deposit 123, then these events are emitted. And this closes the circle. We started at some point with an event storming with real sticky notes, real human beings putting real stickies on a real wall. Went to our desk, started working on code, wrote tests for our code, run our tests, and get the same visual documentation back out, right? And if we do this not just for a single test, but for all our tests, for all our command processors, or for the projectors that look at events to create the read models, then we can get a map of our software based on the events, and we see we have these units of code that read these events, that emit these events, that consume this read model, that produce this read model. And this is more on the architectural side of things when it comes to mapping our event-based software. Now I pushed the wrong button, sorry about that. Where this is more like the domain level of documentation. This is something that I can show to someone who is not a technical person on my team. Hey, I implemented depositing money into the bank account. Does this make sense? And of course, I will have more than one test for, at least I would hope so, for my deposit money command processor. So I'll get 3, 4, 5 of these graphics, and they can look at that and see something that they remember, that they can relate to from the event storming workshop. And they can say, yes, this is exactly what we had in mind, or point out, no, apparently we have a misunderstanding. Like in my head, it was completely clear that this sticky meant that, and now it is this. And this helps everyone involved to get to a shared understanding and find these things as early as possible. Whereas this, more like architectural map, tells me, okay, I need to implement a new feature and this feature relates to these events. What do I need to care about while working on this new feature or while fixing this bug? What are the relationships between the different parts of the system? Who is all interested in this event? Where could something possibly go wrong? And I think that this is, or can be at least, very helpful. So we've already seen that. Now I would like to show you how to actually get these nice, at least I think they are nice, but they are as nice as I, as a technical person who creates these visualizations through code, as you will see in a bit, can get it. I'm not a graphics person, sorry about that. Okay, so this is what the event test case looks like. Obviously, it extends PHPUnit framework test case and adds some additional functionality on top of it, namely the given, when, then methods. So when given is called, we store the events that are supposed to be given, are supposed to be the input, the fixture for our current test. We configure a test stub for the component that usually reads events from the event store, which is the event reader. And we configure that to return hard-coded the list of events that was passed to given. In addition to that, we record the events, including like this class and this string representation of that event and things like that. Why we do that, you will see that in a moment. Very similar for when. We have some code that selects based on the command which command processor is responsible for. In the current iteration of my example application, this is something that needs to be maintained, but I'm sure that through like manually maintained when you add a new processor, that this processor for method needs to be expanded to know about this new processor. I'm pretty sure that through some use of metadata in the form of attributes or things like that, we could easily implement auto-discovery for that. Then we process the command. We actually call the code that we want to test, and we store the information which command was executed, and then the then method, hard to say, we configure basically mock objects under the hood and assert that event objects are equal. We store the information, and this is finally the feature in PHPUnit that I mentioned earlier that I do not think I ever publicly talked about. There's a method in PHPUnit framework test case that is called provide additional information. And it is really boring in the sense that it does exactly what the name suggests. You give it a string, and what the format, what the markup, what the structure, what the meaning of that string is up to you. What happens is that PHPUnit will, for its own event system that is used for debugging, for producing all the output that you see of PHPUnit, emit an event, hey, this test that is currently being run provided additional information. In this case, I'm using a JSON structure with the given, then information that we collected earlier when these API methods were called. And our own PHPUnit extension can consume information later and turn it into pretty graphs. If I just mentioned debugging and PHPUnit's event system, if you want to see what is going on inside PHPUnit under the hood when you're running your tests, just use --debug and you will see a lot of information, probably more than you ever wanted to see. But grep is your friend. It's easy to filter the events that you're interested in. And this is a feature that is usually used when you have a lot of tests and you run your tests and somewhere in the middle PHP crashes. And you would like to know which test is responsible for this crash. Then you use --debug, grep on test prepared, because that is the name of the event that the last event that is emitted before your test code is called, and that will tell you exactly, okay, PHPUnit started to run this test, and then it crashed, and then you know where to start debugging. In this case, I'm showing you the output of --debug because here test provided additional information. That is the event that comes from our method call, and we see our given when then structured information that is transported via the event system to a piece of code that is a PHPUnit extension. PHPUnit extension is registered in PHPUnit's XML configuration file. In this case, the name of the extension is extension. I was not really creative at the time, but it works. It's an example extension, so maybe that's good enough. Our example extension takes two parameters, a directory where the graphics files, where the visualizations are to be stored, and our desired format, and formats supported are PDF, SVG, PostScript, basically everything that is supported by GraphViz, which is what I use to render these graphics. And then we have our extension class that we just registered in the XML configuration file for PHPUnit. It implements the extension interface from PHPUnit. It needs to implement a single method, which is called bootstrap, which is how PHPUnit registers and initializes the extension. And you get from PHPUnit a value object that represents the configuration of PHPUnit, which is the combination of the default configuration, on top of that the XML configuration file, on top of that the CLI option, so you can figure out in your extension, if you need that, in this case we don't, how PHPUnit is currently run. Maybe you are interested in, is the user using colors in the output or not? And depending on that, you adapt your output that you may produce. The parameter collection is parsed from PHPUnit for you, the part of the XML configuration file that we've just seen. And we default the target directory to /tmp. If target directory is given, we set it to that. We then create the directory, make sure that it exists, and error out if it doesn't. The default format is dot, which is the language, the markup language for graphs in the GraphViz utility. And then we register two subscribers, and a subscriber is something in your extension that subscribes to events from PHPUnit's event system. In this case, we are interested in additional information provided. And test runner finished. Test runner finished is the event that, not at the very end of test execution, but at the point in time when PHPUnit knows, okay, I have executed all the tests that are supposed to be executed, and you can hook into that because then you have all the information that you need, and then you can just draw the pretty graphs. And test provided additional information, takes the information from the string, decodes that, does some data manipulation, cleans up the data, brings it into a different structure, stores that over all the tests so we can draw the architecture map. And I will not bore you with the PHP code that generates the dot files because I'm also running out of time. Sorry about that. Yes, so you hook with your extension into PHPUnit, you subscribe to events. You should only subscribe to the events that you're interested in. And in this case, we just write these documents that I showed you earlier. So in a nutshell, what would I like you to take away from this presentation? A collaborative modeling technique like event storming really helps in creating a shared understanding between all stakeholders in the project so that everyone has the same understanding what it is that the software is supposed to be doing. Domain-driven design, command query, responsibility segregation, event sourcing, and other patterns are very powerful and can really help with writing maintainable software. And together they unlock an elegant truth when you align your tests with your domain language, as at least that's what I tried to bring across with my examples. If you use the language like given, when, then, and use the events like I showed you, we can customize our test framework and adapt it to the architecture and design of the application we're testing. And then testing is no longer a burden, but a bridge. And from requirements to code to documentation, the full circle closes. Your tests verify that your command processors emit the right events. And along the way, we use the information to generate visual documentation in event storming's notation, turning tests into living artifacts that keep your team aligned and are not just a chore that you need to do. And yeah, which to me they never were, but then again, I'm weird, I created a test framework, so take that with a pinch of salt. And with that, I would like to leave you. I was about to say thank you. I'll get there. This presentation has a home on the web. You will already now find a PDF of the presentation material that I used, a link to the GitHub repository with the complete example, as well as an article that I just published today with a summary of what I tried to bring across here today in the presentation. I did not introduce myself at the beginning. Don't worry, I'm not going to do that now. But I would like to tell you that doing open source does not put a roof over my head or food on my table. So I need to make a living, and the best way to support my work on PHPUnit is to engage with me professionally. I can help you build better software, test your software better. Details on how I could help you and your team you'll find there. And one final thing, the PHP community is working really hard on creating our own online spaces that are not dominated by algorithms. So if you want to use something like the thing that used to be called Twitter, have a look at PHPC Social. That's also where you can find me. If you want to see great video content about PHP from PHP people for the PHP community, have a look at phpc.tv. I really hope that at some point in the future, more and more conferences will at least not only upload video recordings of presentations to YouTube, but also in addition to phpc.tv. And if you'd like to learn a little bit more about the background of why the PHP community is doing that, there's another QR code for that. And now, thank you for bearing with me. Thank you for your attention. Thank you, and I wish you a great rest of the conference. If you have any questions, I'm here all day. Feel free to approach me and ask me anything, as long as it has to do with PHP, PHPUnit, and software development. Please don't talk to me about dancing or music or some other stuff that I definitely am not an expert in. Thank you.